everyone, welcome back to our channel. Today we are going to solve this problem. So problem given is, for the circuit shown below, find the voltage across V2 and define the voltage V2, and B part is find the current I and find the resistors R1, R3 and prove that power delivered is equal to power absorbed. When you see this problem, it's very simple to understand. So first we need to find out the current and V2. So when you see here, we need to apply KVL. Okay. So in order to link all the voltages. So the voltage across R1 is 18 is already given. The voltage across R3 is already 15 is given, and we need to find this voltage. So here I'm going to link all the voltages. So when the current of I is flowing and to this resistor, current enters at positive terminal, current leaves at negative terminal, and terminals are marked. So now I'm going to apply the KVL inside the loop. So apply Kirchhoffs voltage law inside the loop. Okay, so this is called as loop, or this is called as mesh. Okay, so current is leaving, or the leaving polarity of the voltage is 60. I'm writing this KVL with respect to leaving terminals, such a way that it will be clear with respect to what I'm solving this problem. So current is leaving, but the leaving terminal of the voltage, this is plus 60 volts. And here again current is leaving, or the leaving terminal of the voltage minus 18. And current enters at positive, current leaves. So current is leaving, or the leaving polarity of this voltage, which is nothing but minus V2. And current leaves, or the leaving terminal of this voltage, minus 15 is equal to 0. Here you can see here, when you solve it, so this is nothing but 60 minus 18 minus 15 is equal to V2, where V2 value we are going to get it as 27 volts. So therefore the voltage across V2 we have been obtained as 27 volts. And next we need to find out current I. So how to find the current I? So very simple. Okay, so current I we can find out. So this is the current. Okay, so what is the positive voltage, which is 27 volts? What is the voltage at this point? 0. So here I can write down the current by nodal analysis. Current I is equal to V by R. Okay, so what is the voltage? High potential minus low potential. High potential is how much? 27 minus 0 divided by R is how much? 9. So 9 ones are 9 threes are. So you are going to get a current of 3 amperes which is flowing. So current I is equal to 3 ampere, voltage V2 is equal to 72 volts. So now you can see here this current I is flowing. Okay, this is flowing from this point to this point. So how to write down the current here? So current I is equal to, the formula is V by R. Okay, so what is the voltage we have is 18 minus 0 by R. R is how much? R1. What we need to find out. So already I is known. So R1 is equal to 18 by I. So 18 by I. What is I given in the problem? 3 ones are, we're going to get it as 3 amperes. I mean, we're going to get the R1 value as 6 ohms. Okay, 6 threes are 18. So we're going to get the value of R1 is how much? 6 ohm. So similarly, the current I is flowing in this direction. The current I is flowing. So how we can write down this current? Current I is equal to V by R. Okay, so what is the voltage? We are having 15 volts by R. What is the value of R? We don't know. That what we need to find out is R3. But what is the value total current which flows in this branch is 3 ampere. So that is equal to 3. So from here R3 is equal to 15 by 3, where R3 is how much? 5 ohm. So successfully we find the value of R3 is 5 ohm. So this is 6 ohm. Now I'm going to redraw for your clarification. So after solving, R1 value is how much? 6 ohm, and this is an another branch, this is an another branch. So the value of this one is 9 ohm. The value of this after solving R3 is how much? 5 ohm. Okay, so here we are applying an voltage of 60 volts. So what are the drops created here are, so with positive terminal and negative terminal, already it is mentioned, this is 18 volts. Okay, so here it is, we obtained it as 27 volts, and here we obtained this value as 15 volts. So whether we have got correct or not, let's try to apply here. Okay, so try to apply Kirchhoff's voltage law. Already we had done it. You can see this voltage law. So current, what is the amount of current flowing in the circuit is 3 ampere. So current is leaving. What is the leaving polarity? Plus 60. And current is leaving. What is the leaving polarity across 6 ohm? Minus 18. Current is leaving. What is the leaving polarity across 9 ohm? Which is nothing but 27. Current is leaving. What is the leaving polarity of the voltage? Minus 15 is equal to 0. All this negative term is sent to this side. So 60 volts we are applying, creating a drop of 60 volts. I can say the circuit is balanced. And we want to prove that the power delivered is equal to power absorbed. Okay, so we can see here current is same. So now power delivered. Okay, so power from the source is nothing but power from the battery is equal to power delivered. So what are the elements which are delivering power delivered by, what is this resistor? 6 ohm. What is the power delivered by next element is 9 ohm. Power delivered by the next element is how much? 5 ohm. The formula for this power, you can use the formula V into I, or you can use I square R. Okay, so comfortably I am using V into I. So what is the voltage across the 6 ohm? Voltage is 18 volts current, constant current. Why? Because these three are connected in series. You can say 6 ohm, 9 ohm, 5 ohm, all these three resistors are connected in series. That's why current of 3 amperes is constant. Now, what is the power across 9 ohm resistor? What is the power across this 9 ohm is? So the total voltage is how much? So here a voltage of 27 volts is flowing, a current of 3 amperes is flowing. So what is the power across 5 ohm resistor? So totally 15 volts and a current of 3 amperes. So when you do the product, you are going to get 18 into 3, which is nothing but 54 watts. So 27 into 3, you are going to get it as 81 watts, and 15 into 5, you are going to get as 45 watts. And 54 plus 81 plus 43, you are going to get the power absorbed is 180 watts. So the power absorbed by 6 ohm resistor, the power absorbed by 9 ohm resistor, the power absorbed by 5 ohm resistor, which is nothing but 180 watts. And what is the power from the source? So what is the voltage of the source? 60 volts supplied by the battery multiplied by the current supplied by the equipment is, so 60 into 3, which is nothing but 180 watts. Whatever the examiner has asked, it is proven. So the power delivered is 180, and it is absorbed across 6 ohm resistor as 54 watts, and across 9 ohm resistor as 81 watts, across 5 ohm resistor as 45 watts. You can see here KVL is verified, and power delivered by the battery and power absorbed by the all three resistors are also verified. I can say here very simple to understand. This is a series circuit where 6 ohm, 9 ohm, 5 ohm are connected in series. The voltages develops are 18 volts, 27 volts, and 15 if you add, which will be equal to 60. That's how we are applying KVL. And power delivered is equal to powered observed. So hope you understood this problem. So directly observe the problem, nothing comes to your brain. Just listen the methodology how I have been solved and try to solve of your own. So if you feel the content is useful to you, please like the video and share with your friends. And if you have any doubts, let me know in comment section. And if you are watching the channel for the first time, subscribe the channel. This is a free channel for the development of students. Thank you for watching. Yours Ram.